On a seaside beach, a beer bottle washed ashore lies quietly, its edges smooth and its surface still glimmering. You might think it is merely a relic from decades past, yet from the perspective of materials science, its journey may have only just begun. Human memory might span only 100 years and the traces of civilization may weather away in 1,000, but glass, this seemingly fragile substance, possesses the patience to endure across geological eras. Scientists have boldly speculated that, left undisturbed by human activity, a glass bottle could indeed persist for millions of years, perhaps even 2 million. This is neither a joke nor an exaggeration, but a conclusion drawn from its very physical nature. Many people lump glass together with plastic as non-degradable waste, viewing both as hallmarks of modern industrial pollution. Yet from a materials science standpoint, such a comparison is entirely misplaced. Glass is primarily composed of silicon dioxide, a substance nearly identical in composition to natural quartz, volcanic rock, or sand. You can find its relatives on beaches, in mountains, and throughout the Earth's crust, but you can hardly identify any true adversaries. Whether bacteria, fungi, seawater, or high temperatures, none has a significant effect on glass. The hardness of glass stems not only from its stable chemical composition, but even more critically from its amorphous structure. Unlike metals or crystals, which exhibit orderly atomic arrangements, the atoms in glass resemble a frozen liquid, random yet densely packed, leaving almost no gaps for natural elements to exploit. This grants it a remarkably rare property. It neither corrodes nor degrades. It's true that glass shatters easily, which might lead us to mistakenly equate fragility with a lack of durability. However, this is merely a reflection of its poor impact resistance, not an indication of inferior longevity. Even if a glass bottle breaks into 3 or 5 pieces, as long as there are no chemical reactions or severe abrasion, it retains its original properties. Wind and rain can wash away surface dirt, microbes find nothing to eat in its inorganic matrix, and although ultraviolet light may break down plastics, glass, transparent and chemically stable, does not undergo photochemical reactions. Unless you throw it into volcanic lava or immerse it in a strong alkaline solution, it remains a substance seemingly too inert to react. Research by the U.S. National Oceanic and Atmospheric Administration on marine debris has estimated that the natural degradation of a glass bottle exceeds 1 million years. Material engineering reports further indicate that in dry, low-temperature, and stable soil conditions, the degradation rate of glass is effectively negligible. This means that, as long as it remains undisturbed, it can leave its mark almost indefinitely. Our conclusions are not baseless speculations. Archaeological teams in the ancient sites of Egypt, Iraq, Italy, and elsewhere have repeatedly unearthed glass artifacts dating back 2,000 to 3,000 years. While some objects display weathering or oxidized surfaces, the vast majority have maintained their clear shapes, robust texture, and functional integrity. For instance, beneath the volcanic ash in Pompeii, archaeologists discovered glass cups, ornaments, and window pane fragments that still reflected light upon excavation. These items, whose compositions are strikingly similar to modern glass, withstood volcanic eruptions, high temperatures, immense pressures, and millennia of humidity underground, yet remained virtually unchanged. Thus, modern industrial glass, of higher quality, with fewer impurities and a more uniform structure, if left to nature's devices, could conceivably endure 10 times longer than Roman era glass. This is not myth but a scientific possibility. Of course, we must acknowledge one fact. The Earth is not a museum but a planet in constant flux. Waves erode, sands wear down surfaces, tectonic shifts, earthquakes, and volcanic eruptions can shatter rock, and given enough time, may likewise fracture glass, bury it, or mix it into sediment layers. Glass can indeed persist for 2 million years, but only if it is lucky enough not to be tossed into a rubble pile by the surf or fall into the cracks of shifting tectonic plates. Yet if it is eventually buried underground, weathered into fine particles, and incorporated into rock layers, it ceases to be a glass bottle and becomes a natural mineral, an integral part of the Earth's evolving tapestry, continuing to exist in another form. Viewed from this angle, glass is not merely a material. It may very well be the most enduring, last testament of human civilization left on our planet. A million years from now, if another species were to excavate today's surface remnants, with wood long decayed, plastic shattered, and paper turned to ash, somewhere, they might still uncover a cola glass bottle, clearly stamped with its manufacture date, 2025. No language and no explanation would be needed. It would simply reveal that it was crafted by an intelligent species capable of harnessing fire and processing silicon. A glass bottle, thrown away in just a second, could leave behind a legacy spanning 2 million years. It will neither deform nor degrade, be consumed nor forgotten. It simply rests quietly in a corner, silently recording the trace of our existence. So the question is not, how long can it last? But rather whether we are willing to let its lasting presence be a dignified legacy. Recycling it, remanufacturing it, repurposing it, not merely for conservation's sake, but to honor time, civilization, and every creation we have brought into being.